In this tutorial series about ComfyUI, I'll not only be going over workflows, but showing you how to construct them for yourself, with the goal of helping you to understand nodes and how they work. We'll also be looking at the different nodes that are available for you to choose from. We'll begin with some basics. If you find nodes in the spaghetti tangle of connections intimidating, then try thinking of them in more familiar terms. The first group is organized into checkpoint models and LoRa's. You can think of checkpoints as the recipe book, and LoRa's as the spices that change the flavor to more of a southwestern spicy taste or an Italian flavor. The next group is the prompt, or in our analogy, the menu, where you can tell the chef what you want. The third group is where all the work takes place, the K-sampler, or in our version, the kitchen. Putting it in these terms helps a lot of people to make sense of what is going on and how the information flow has to operate. Let's start with the basic default workflow. The load checkpoint node is where we select the checkpoint model we wish to use to generate images. The clip text encode node is where we type in our prompt. We'll need two of them, one for positive prompts and one for negative prompts. We also need the empty latent image node. This provides the information on the dimensions of the image to be generated. You can think of it as the size of the canvas to be painted on, or in the previous analogy, how big the portions are to be. The K-sampler node is where everything comes together and the image is generated from the information provided by the other nodes. The K-sampler output must first be decoded before it can be presented as an image. The K-sampler node output is marked as latent, and the VAE decode node input is marked as samples. The final node saves the generated image. To generate an image, we simply click on the Q prompt button in the menu. Now let's change our checkpoint to an SDXL model, Juggernaut, which is one of my favorites and is known for generating good faces and highly detailed images. We'll change the prompt to a beautiful woman composed of fire, walking through a forest, masterpiece, high detail. We'll use the Lightning version, which only needs 8 steps to generate a good image, which makes it very fast. The recommended image size is 832 by 1216. The result looks pretty good, but I want more fire and a more dramatic look. Let's add a LoRa to spice it up. Double-click on the background and type Load LoRa in the search box. We'll need to place the LoRa between the checkpoint and the prompt and K-sampler. Remember, the LoRa is a modifier for the checkpoint. Reconnect the model string or noodle so the information flows from the checkpoint through the LoRa and then to the K-sampler. Then reconnect the clip string to flow from the checkpoint into the LoRa and out to the positive prompt. We don't have to worry about the negative prompt. We'll select a LoRa that adds fire to the image. Some LoRa's work best if certain trigger words are used in the prompt. In this case, composed of fire triggers the LoRa. Civet AI is a good source for LoRa's, but be advised that there is a lot of adult content on their site. We'll click Q prompt and the image will render quickly. Let's add another LoRa to intensify the effect. You can select the node and then press Alt and left click to duplicate and drag the new node into position. We'll need to reconnect the first LoRa to the second LoRa by moving the model connection from the K-sampler to the second LoRa, and then attaching the second LoRa to the K-sampler input. We'll reroute the clip string as well. We want the information to flow from the checkpoint through both LoRa's and then to the prompt and the K-sampler. We'll select a LoRa that adds a lava effect and enter the trigger words Real Lava into the positive prompt. Then we'll generate a new image and see the results. This image is generating in real time on a RTX 4060 card with 16 gigs of video RAM. The cost was $500. We can add as many LoRa's as we wish and daisy chain them together. But that gets messy and crowded. There is an alternative way, and that is to use a node that can contain 3 LoRa's and a switch to turn each on and off individually as we need them. We can select which LoRa's we want to place in the node, and we can adjust the settings for each individually. We'll add the CR LoRa stack and also the CR apply LoRa stack, which is needed to connect the stack to the workflow. This will give us a much neater workflow and make it easy to find and use our favorite LoRas. It's a great convenience that I wasn't aware of for a long time. It saves from having to scroll and search through a long list of LoRas that I have collected, many of which I seldom use. We reattach the model string just as we would to a load LoRa node, and the same with the clip strings. Then connect the LoRa stack to LoRa stack terminals. If we need more than 3 LoRas, we can even daisy chain multiple stacks together. We can then turn off the LoRas we don't want to use and turn on the LoRa we want, such as this comic LoRa. To further help us organize our workflow, we can group nodes together. This allows us to put nodes together in a logical configuration according to specific tasks that those nodes perform, and it has an additional benefit. By grouping our nodes together, we can move the entire node configuration around as a single unit, which is often handy when building workflows with additional functions such as image-to-image node groups. It also allows us to bypass an entire group of nodes instead of having to go through and bypass them individually. Let's add an image-to-image workflow onto our existing workflow. We'll make a little room between the prompt windows and the K sampler, because this is where the information needs to enter. Since we're using a ControlNet image-to-image scheme, we'll need a load ControlNet model node, just as we needed a checkpoint model before. Next, we'll need a load image node. And a good option is to have an image resize node, although it is not absolutely necessary. We'll also need a ControlNet preprocessor and a apply ControlNet node. I like the advanced version. We'll connect the nodes in the order in which the information needs to flow. Beginning with the load image node, we connect the image out terminal to the image input terminal on the resize node. Then the preprocessor node, and finally to the apply ControlNet node. The apply ControlNet node has an input for the ControlNet, which is where we connect the load ControlNet model to the apply ControlNet node. The ControlNet information is introduced between the prompt nodes and the K sampler, which makes sense, as the K sampler has to be told what the final image is to look like. The positive and negative terminals are clearly marked on the apply ControlNet node, which makes rerouting the noodles easy. Now that we have everything connected, we can do a little house cleaning and tidy things up a bit. We'll rearrange our nodes into a more compact space and put them into a group. To use the image-to-image group, we'll first have to adjust the settings. The image resize node should be set to the same dimensions as the brown empty latent image node above. Otherwise, our final image will be distorted. Next, we'll select a ControlNet model to use. There are several to choose from. The Canny model will make a line art representation of the image and will act as a guide for the K sampler to use. This is good for keeping many of the finer details in the loaded image reproduced in the final generated image, such as fingers and such. We'll also set up an image preview node so we can see exactly what information is being passed on to the K sampler. This is kind of like checking the customer's order before it goes to the kitchen. We'll turn off all the LoRas and change the prompt to Chris Hemsworth as Conan the Barbarian, standing in a rocky canyon, cowboy pose, masterpiece, high detail, 4K photorealistic, cinematic. Then we'll run the workflow to generate the image. We can see the line art image generated by the Canny ControlNet and how it has influenced the generated image. It's a good match, but I'm not happy with the background. It's too foggy and lacks detail. I like to put a preview image next to my prompt in LoRa's so I can easily make adjustments and see the results without having to pan around the workflow. This allows rapid changes to the prompt and the ability to turn LoRa's on and off and apply them in different combinations. I can even change the checkpoint model to see which one gives me the best effect. And everything is within view, so I can compare the results on the big preview window without having to spend my time maneuvering the workflow, nor do I wind up with a lot of saved images that I don't want and have to delete later. By keeping the seed on the K-sampler fixed, I can easily judge the effects of the changes that I make to the prompt and other settings. For instance, the control net. By changing the control net model from a line art setting to a depth mask, the K-sampler has greater flexibility in generating the image. Let's look at another method to do image-to-image generation. First, we'll delete the control net nodes, then we'll insert a load image node, followed by a prep image for clip vision node, and finally, an IP adapter style and composition SDXL node. Then we'll duplicate the load image and prep image for clip vision nodes. We'll be using both the loaded images to influence the image we're going to generate. One will be for the style, and the other will be for the composition. If you can't find the IP adapter we are using, be sure to go into the manager and update your ComfyUI, or update all. It should then be available to you. Next, we'll connect all the nodes, starting with the image terminals on the load image node, prep image node, and IP adapter, making sure we connect the top two nodes to the image style terminal and the bottom two nodes to the image composition terminal. And finally, we'll connect the IP adapter unified loader to the IP adapter from the model out terminal to the model in terminal, and the IP adapter terminals from the loader to the IP adapter. For the sake of convenience, I've moved the entire group to a position above the rest of the workflow. We'll need to connect the model out from the Apply LoRa stack to the IP adapter unified loader, and from the IP adapter to the K-sampler. This will insert the group between the LoRa's and the K-sampler. We also have to reconnect the prompt nodes to the K-sampler, because those connections were broken when we deleted the earlier control net group of nodes. And of course, I like to have a preview node handy, so we'll put one of those next to our new group. I'll also make some adjustments to the preview nodes in our group in order to give them a bit more room and make them easier to view. Now all we have to do is test to new configuration to make sure it works and gives us an image similar to the input image. And boom, it works. It's always nice when everything works and you don't get any red error messages. Now we'll change the first input image to an image with a totally different style. The information from the comic style image will flow to the IP adapter and into the image style terminal, while the information from the lower image will flow into the image composition terminal. The IP adapter will merge the two images and give us a new original image. We can adjust how much influence each image has on the final generated image by adjusting the weight or strength of each input. We'll drop the style input down to 0.5 and regenerate the image. By utilizing different images for our style, we can give the final image a totally different look, giving us much more creative control than with the control net nodes. And the style input image does not have to have any resemblance to the composition image, as this image of a wood carving demonstrates. I hope you enjoyed this video tutorial. Be sure to subscribe so you don't miss any of our upcoming ComfyUI videos.